Exercise 7.6 is asking you how the rate of this second order rate equation, how the rate of this reaction is going to speed up when you change the concentrations of different reactants. Now you see the word second order and instantly you should be thinking SN2. That's one of the things that the 2 is referring to. And we talked about that a little bit when we talked about the rate law in the video on understanding substitution reactions. How that's a second order rate law because it depends on two things, the substrate and the nucleophile. So the fact that it's second order means that's the rate law we're going to use. Rate equals K, which we talked about was just, there is a conversion factor for units, and the rate for an SN2 reaction depends both on the substrate and on the nucleophile. And if that doesn't mean anything to you, I encourage you to go back to the video for understanding substitution reactions where we derived this whole table. So that's the rate law. We knew to use this rate law because it said that it was a second order reaction. So in each of these different cases, we're going to use this rate law. Okay. Next, what we have here is the substrate and the nucleophile. Remember that the substrate is the carbon chain with the leaving group. And the nucleophile is the thing that has the negative charge. You have a metal and a non-metal here. Anytime you see metals in organic chemistry, you should think, oh my gosh, that's giving away its electrons. It's an ionic bond. The metal has a positive charge, and the hydroxide has a negative charge. So the hydroxide is going to be our nucleophile. And the name for NaOH is sodium hydroxide. Okay. So we see that it's second order, so we write down the second order rate law, and we've identified what is the substrate and what is the nucleophile. So now let's see how they're making those change. So they ask what happens to the rate if the concentration of 1-iodopropane, that's our substrate, is tripled and the concentration of sodium hydroxide, that's our nucleophile, remains the same. So what you want to do is you want to compare this to a case where the concentrations are 1. So just imagine a scenario where the concentration of the substrate and the nucleophile are 1. In that case, the rate would be 1. Okay. So here they're asking what would happen, and let me just color code these so it's a little easier to follow. Substrate and nucleophile. So what happens if iodopropane, 1-iodopropane, and that's the substrate, is tripled? So now instead of 1, that would be 3. And the concentration of sodium hydroxide, that's our nucleophile, remains the same. So that stays as a 1. So using this first example of everything being 1 allows us to think about tripling or staying the same in very clear terms. Well, you multiply these. These are being multiplied. And so if the concentration of the substrate tripled and the concentration of the nucleophile stayed the same, then the rate would triple. It would be 3 times 1, or 3. And you can see that that's 3 times larger than the original rate. So you would say, the rate would triple. For B, again, in all of these we're dealing with a second order rate equation. That means they're all going to be SN2. And the rate law for an SN2, the rate depends both on the substrate and on the nucleophile, because the nucleophile is involved in that rate limiting step, that first step. It attacks you have nucleophilic attack and loss of a leaving group. Both the substrate and the nucleophile are involved. So we're going to compare everything to a case where the concentrations are just 1, and so the rate is just 1. So they say, what happens color code these. So it says, what happens to the rate if the concentration of 1-iodopropane, that's our substrate, remains the same, so that'll stay 1, and the concentration of sodium hydroxide, that's our nucleophile, is doubled. Well, if it starts out as 1 and you double it, it becomes 2, You multiply these, and the rate would double. This last one says, what happens to the rate if the, and here let's just color code these quickly again. So our nucleophile will be in blue, and our substrate will be in purple. So it says, what happens to the rate if the concentration of 1-iodopropane, that is our substrate, is doubled? So if it starts out, we're always comparing to a case where everything is 1. If the substrate doubles, then that becomes 2. And the concentration of sodium hydroxide, that's our base, is tripled. So if it starts out as 1, it becomes 3. It's tripled. Well, multiply that, and you get 6. The rate increases by a factor of 6. So you'd say the rate would be 6 times faster. So that's this exercise. The first thing you want to do is to understand how, this is second order and therefore SN2 and therefore has this rate law. And to understand that conceptually, go back to the video for understanding substitution reactions. Once you're able to recognize that, this is the rate law for an SN2 reaction, which is second order. Identify your substrate and your nucleophile. Plug in 1 underneath each rate, and then based on what they tell you, change the numbers of the 1s. Multiply them together, and you get how much faster the new rate would be.